All right, so today we're talking about elimination using multiplication. So we're going to solve system of equations by using elimination with multiplication and solve real-world problems involving systems of equations. So the table shows the number of cars at Scott's Auto Repair Shop for each type of service. The manager has allotted 1,110 minutes for body work and 570 minutes for engine work. The system 3R plus 4M equals 1,110 and 2R plus 2M equals 570 can be used to find the average time for each service. In the system above, neither variable can be eliminated by adding or subtracting. But you can use multiplication to solve. And that's what we're going to look at today. So there are 3 steps, just like in adding or subtracting. So the first step is multiply at least one equation by a constant to get 2 equations that contain opposite terms. Then you're going to do just like the previous lesson. You're going to add the equations, eliminating one variable, then solve the equation. And then step 3, substitute the value in step 2 into the one of the other 2 equations and solve for the other variable. Write the solution as an ordered pair. So let's see how that's done. So in this example, we are to use elimination to solve for the system of equations. We have 5x plus 6y equals negative 8 and 2x plus 3y equals negative 5. Now you will see that the x's or the y's have different terms, okay? The constants in front of them are different terms. So, or the coefficients, in front of them are different terms. So, what we want to do is we want to be able to change one of those to where they're the same term. Well, how can we do that? We could multiply the second equation by negative 2. And when we do that, we have negative 2 times 2x would give me negative 4x. And we have negative 2 times 3y would give me negative 6y. And negative 5 times negative 2 would give me a positive 10. Now you'll notice that the y term is one's positive, one's negative, but now they're both 6y. So now I can just add the 2 equations together. 5x minus 4x is x. The 6y's cross out, and negative 8 plus 10 would be 2. So my x is 2. Now I just go over to either one of the 2 equations, and I would do the original equations, and then I would plug in the 2 for the x, which is what's done over here. And we have 2 times 2 is 4, subtract 4 from both sides, we get 3y equals negative 9, divide both sides by 3, and y equals negative 3. So our solution would be 2, negative 3. All right. Sometimes, though, you have to multiply each equation by a different number in order to solve the system. So, for example, we have 4x plus 2y equals 8 and 3x plus 3y equals 9. Well, there's nothing I could multiply to one of the equations to get a term that's opposite each other, okay? So what I'll have to do is multiply something by each one in order to get a term that's the same. So for example, on the 4x plus 2y equals 8, I could multiply everything by 3, okay? That would give me 12x plus 6y equals 24. And then on the 3x, I can multiply everything by negative 4. And that would give me negative 12x minus 12y equals negative 36. Now my x's are the same. They're both 12x. One's positive, one's negative, so all I have to do is add the 2 equations, and the x value will go away. And so then I'll just have 6y minus 12y would be negative 6y, and 24 minus 36 is negative 12. I divide both sides by negative 6, and y equals 2. And then just like we've been doing, we plug 2 in for y in one of the original equations, and we solve for x. And that's what's done right here. So we'd have 3x plus 3 times 2, or 6, equals 9. Subtract 6 from both sides, we get 3x equals 3. Then we divide both sides by 3, x equals 1. And we would have a solution of 1, 2. Okay? all this method 2 is just simply saying you could do it the opposite. In other words, you could do the y's instead of the x's. It doesn't matter which one you do. So in this case, if I multiply the first one by 3, I get 12x plus 6y equals 24. And if I multiply the second equation by negative 2, I get negative 6x minus 6y equals negative 18. And then when I add them together, I get 6x equals 6, because now the y's are gone. And divide both sides by 6, x equals 1. So we still get the same x value. And then when you come over here and you substitute 1 in for x, you're still going to get the same y value, and you get the same solution. So it doesn't matter whether you're multiplying to get the same x value or you're multiplying to get the same y value. It's just one or the other. You pick which way that you want to do it. Okay? And then, of course, if you want to check your solution, all you need to do is to plug in one of the original equations, plug in what you got for x, plug in what you got for y, and it should, each side of the equal sign should equal. Okay? If it does, then you know you've got the right answers. If it doesn't, you got the wrong answers. All right. So try this one, come back and see how you did. All right, let's try this one together, and then I'll give you another one to do on your own. So on this first one, I can multiply everything by 2. And on the second one, I can multiply everything by negative 3. Then that's going to give me 6x minus 4y equals negative 14. And that's going to give me negative 6x plus 15y equals negative 30. Then I'm going to add the 2 together. The x's will cross out, and that'll give me 11y equals negative 44. Divide by 11, and y equals negative 4. Then I can go back to the original equation, and I could say 3x minus 2 times negative 4 equals negative 7, or 3x plus 8 equals negative 7. Subtract 8 from both sides. 3x equals negative 15. Divide both sides by 3, and x equals negative 5. So my solution would be negative 5, negative 4. Okay? Now I want you to try 3x plus 4y equals 27, and 5x minus 3y equals 16. So try that, come back and see how you did. All right, let's see how you did. So I would multiply the first equation by 5 and multiply the second equation by negative 3. And I would have 15x plus 20y equals 135. And I would have negative 15x plus 9y equals negative 48. I would then add both of those together. And I would end up with 29y equals 87. Divide both sides by 29, y equals 3. Then I would plug 3 into the original equation of 3x plus 4 times 3 equals 27. Subtract 12 from both sides, 3x equals 15. Divide both sides by 3, and x is 5. So you should have come up with a solution of 5, 3. Okay. So sometimes it is necessary to use multiplication before elimination in real-world problem solving too. So it says a personal aircraft traveling with the wind flies 520 miles in 4 hours. On the return trip, the airplane takes 5 hours to travel the same distance. This time, it's against the wind. They want you to find the speed of the airplane if the air is still, so there's no wind. So we could let A represent the rate of the airplane if the air is still, and we can let W equal the rate of the wind. And so we need to write some equations. Well, we could say the rate of the airplane in still air plus the rate of the wind, okay? That would be going there because we're flying with the wind. And we know that it takes 4 hours to go 520 miles. Okay? Time and distance. So we could set up an equation for that. We could say A plus W times 4 equals 520, or 4A plus 4W equals 520. Now on the return trip, we're going against the wind. So it would be A minus W, or the still weather minus the wind. And that time for that was 5 hours. The distance was 520 miles. So we could set up an equation of 5A minus 5W equals 520. Now that we have our two equations, we can solve by using elimination of multiplication. So we could just simply multiply the first equation by 5 and the second equation by 4. And now we have our W's are different, they're opposite. One's plus, one's minus. So I could just add. That would give me 40A equals 4,680. Divide both by 40, and A equals 117. Remember, I'm solving for A. That's the traveling in still air. So I don't need to know what the wind is. I just need to know how fast I'm going in still air. So that would be 117 miles per hour. Okay? All right. Try this one, come back, and see how you did. All right, let's see how you did. So during a canoe trip, it takes Raymond 4 hours to paddle 12 hours upstream. It takes him 3 hours to make the return trip paddling downstream. Find the speed of the canoe in still water. So we let C be the rate of the canoe in still water and W be the rate of the water current. Now, when you get these problems, you're not going to get anything below this line, okay? You're just going to get the word problem. The reason I put the table in is just to try to help you organize the information, okay? So you would have C minus W, or 4 times C minus 4 times W equals 12. 3C plus 3W equals 12, okay? So the table just kind of shows how you would get those equations. And then, of course, we would have to multiply the first one by 3, and I multiply the second one by 4, and I get 12C minus 12W equals 36, and 12C plus 12W equals 48. Remember, we're solving for C, okay? So I would end up with 24C equals 84 when I add them together, and I would divide both sides by 24, and C would equal 3.5. So you should add 3.5 miles per hour. Okay? All right. If you got any questions, let me know. Otherwise, have a great day.